Hi, my name is Basir. In the previous video, we learned a few basics of trigonometry that shall help us in solving exercise 11.1 problems. But in the previous video, I wasn't able to continue and work on exercise 11.1. So here we are. In this video, we'll work on exercise 11.1 questions. Here is the first question, which says, in a right angle triangle ABC, 8 cm, 15 cm and 17 cm are the lengths of AB, BC and CA respectively. Then find out sine A, cos A and tan A. Let me quickly draw a right angle triangle ABC with the given measurements. I'll just draw a rough triangle of it. So here we go. We have a right angle triangle ABC. AB is given as 8 cm, BC is given as 15 cm and AC is given as 17 cm. And we have to find out sine A, cos A and tan A values. With respect to angle A, BC is the opposite side, AC, which is a slant line, is always the hypotenuse, and AB is the adjacent side with respect to angle A. Now we know that sine is opposite by hypotenuse, cos is adjacent by hypotenuse, tan is opposite by adjacent. What is the opposite side here? 15, hypotenuse is 17, adjacent is 8, hypotenuse is 17, opposite is 15, adjacent is 8. So we have the values of sine A, cos A and tan A as 15 by 17, 8 by 17 and 5 by 8. Let us go ahead and work on the second problem. The second problem says the sides of a right angle triangle PQR are PQ is equal to 7 cm, QR is 25 cm and angle Q is 90 degree respectively. Then find tan P minus tan R. We'll again draw a right angle triangle. A right angled triangle. Well, I hope it looks like a right angle triangle to you. PQ is 7 cm, QR is 25 cm and angle Q here is given as 90 degree. Now we are asked to find out the value of tan P minus tan R. So we have to find out the value of tan P minus tan R. Let us first find out what is tan P. We know that tan is opposite by adjacent, opposite side by adjacent side. With respect to angle P, QR is the opposite side, PR, which is a slant line, is always a hypotenuse, PQ is the adjacent side. So what is the opposite side here? 25. And what is the adjacent side? 7. So tan P is 25 by 7. In the same way, let us find out what is tan R. Now with respect to angle R, we have to find out tan R, right? So with respect to angle R, this is the opposite side here. PQ becomes the opposite side and QR becomes the adjacent side. What is tan? Tan is again opposite by adjacent. Opposite side is 7, adjacent is 25. So tan R is 7 by 25. Tan P is 25 by 7, tan R is 7 by 25. We can take LCM or else we can just cross multiply this way. 25 into 25 minus 7 into 7 by 7 into 25. 25 into 25 is 625, 7 7s are 49. 25 into 7 is 175. 625 minus 49 should be 576. 576 by 175 is your answer. Tan P minus tan R is 576 by 175. Let us go ahead and work on question number 3. Question number 3 says, in a right angle triangle ABC with right angle at B, in which small a is 24 units, small b is 25 units, and angle BAC is equal to theta, then find cos theta and tan theta. We'll again draw a right angle triangle here. So this is a right angle triangle here. ABC is a right angle triangle. Small a is given as 24 units. Small a is given as 24 units. You just have to remember small a is the side opposite to angle A. So which means this side BC is small a. So BC is 24. So you just have to remember BC is 24. Now small b is 25. Small b, again, it is a side which is opposite to angle B, which means AC is 25. AC is 25. Now I've already told you, if we have two sides of a right angle triangle, it is very easy for us to find out the third side by using Pythagoras theorem. Pythagoras theorem says that hypotenuse square is sum of squares of the other two sides. In the question it is given angle BAC is theta, which means this angle is theta. Now with respect to this angle, BC is the opposite side, AC is, the slant line is always the hypotenuse, AB is the adjacent side. Now let us make use of Pythagoras theorem. Hypotenuse square, hypotenuse is 25, hypotenuse square is sum of squares of other two sides. What are the other two sides? AB and BC. AB I don't know, so I'm writing AB as it is. BC I know it, it's given as 24, so I'm writing 24 here. 25 square is 625. 24 square is 576. So AB square is 625 minus 576, which is 49. Square root of 49 is 7. So I now know that AB is 7 centimeter. What do we have to find out here? We have to find out cos theta and tan theta. Okay, let us find out cos theta and tan theta. We all know that cos is adjacent side by hypotenuse, and sine is opposite side by adjacent side. So what is the adjacent side here? 7. Hypotenuse is 25. Opposite is 24. Adjacent is 7. So cos theta is 7 by 25 and tan theta is 24 by 7. Let us now work on question 4. Question number 4 says, if cos A is equal to 12 by 13, then find out sin A and tan A. Okay, this too is very simple. Cos A is given as 12 by 13. We'll have to find out sin A and tan A. We all know that cos is opposite side by hypotenuse. Sorry, cos A should be adjacent side by hypotenuse, right? Cos A in the question is given as 12 by 13. Cos A is adjacent side by hypotenuse. Let me quickly draw a right angle triangle here. This looks too small, so I'll just draw a little bigger one. With respect to angle A, BC is the opposite side, AC is the slant line which is always the hypotenuse, AB is the adjacent side, right? So I'll do it like this. We can write it like this in the form of a ratio, right? Adjacent side is to hypotenuse is equal to 12 is to 13. We'll take the adjacent side as some 12k or 12x. Adjacent side is 12x. Hypotenuse is some 13x. Okay. So adjacent side is 12x, hypotenuse is 13x. Now when we know two sides in a right angle triangle, it is again very easy to find out the third side using Pythagoras theorem. What does the Pythagoras theorem says? It says that the square of the hypotenuse is sum of squares of other two sides. So what is the hypotenuse here? AC is the hypotenuse. So square of the hypotenuse should be equal to sum of squares of other two sides. The other two sides are AB and BC. I know the value of AC. It is given as 13x. Value of AC is 13x. AB is 12x. BC I don't know, so I'm writing BC as it is. 13 square is 169, 12 square is 144, so BC square should be 169x square plus 144x square. If I take it to the left hand side, it becomes minus 144x square. So the value of BC square is 169 minus 144 should be 25x square. If I remove square from the left hand side, I'll have to put a square root on the right hand side. Square root of 25x square is 5x. So BC is 5x. Now in the question, it's asking us to find out sine A and tan A. Sine A and tan A. Sine, we know that sine is opposite side by hypotenuse. Tan is opposite side by adjacent side. So what is the opposite side here? We can see here the opposite side is 5x. Hypotenuse is 13x. X gets cancelled. The value of sine A is 5 by 13. Opposite side is given as 5x. Adjacent side is 12x. X gets cancelled. So I'm writing it as 5 by 12. Now if you see here, I have taken the ratio here. The ratio of adjacent side and hypotenuse is given as 12:13, and I have taken the adjacent side as 12x, whereas I have taken the hypotenuse as 13x. Instead of doing that, people usually take it as, instead of taking it as a ratio 12x and 13x, people sometimes take it as just 12 and 13 for just to keep things simple. I'll use I will do that while working on the next question number 5. Question number 5, it says 3 tan A is equal to 4. Will have to find out sine A and cos A. So 3 tan A is given as 4, which means tan A should be 4 by 3. 3 is multiplying on the left hand side, so if I take it to the right hand side, 3 will divide, right? So tan A is 4 by 3. We all know that tan is opposite side by adjacent side. So I'll again draw a right angle triangle here. This time I'll keep things simple. Instead of taking a ratio, I'll just try to keep things simple this time. So we have a right angle triangle here, ABC. With respect to angle A, BC is the opposite side. AC, which is the slant line, is always the hypotenuse. AB is the adjacent side. Now opposite side is given as 4, adjacent side is given as 3. I'll have to find out AC. It's pretty simple. According to Pythagoras theorem, square of the hypotenuse is sum of squares of other two sides. So AC square is AB square plus BC square. I'll have to find out the value of AC. AB is given as 3, BC is given as 4. 3 square is 9, 4 square is 16, 9 plus 16 is 25. So AC will be, if I remove square from the left hand side, I'll have to put a square root on the right hand side. So AC is 5. Now from the question, what do I have to find out? I'll have to find out sine A and cos A. Sine A and cos A. Sine is opposite side by hypotenuse. Cos is adjacent side by hypotenuse. So what is the opposite side here? 4, and hypotenuse is 5. Adjacent side is 3, hypotenuse is 5. So sine A is 4 by 5 and cos A is 3 by 5. I'll skip question number 6 for now. I'll be doing question number 6 towards the end of this exercise. I'll just move on to question number 7 for now. Now let us work on question number 7. Question number 7 says that cot theta is 7 by 8. Then evaluate 1 plus sine theta into 1 minus sine theta by 1 plus cos theta into 1 minus cos theta. So here cot theta is given as 7 by 8. Then we have to find out 1 plus sine theta into 1 minus sine theta by 1 plus cos theta into 1 minus cos theta. Let me again draw a right angle triangle here. I am naming the right angle triangle as ABC. Let this angle A as theta. Now we know that cot is adjacent by opposite, adjacent side by opposite side. So with respect to this angle theta, BC is the opposite side, the slant line AC is always the hypotenuse, AB is the adjacent side. So AB is 7 and the opposite side BC is given as 8. I've already told you, if we have two sides of a right angle triangle, it is pretty simple to find out the third side using the Pythagoras theorem. AC square is equal to AB square plus BC square. AC I don't know, so I'm writing it as it is. AB is 7, BC is 8. So AC square is 7 square is 49, 8 square is 64. 49 plus 64 should be 113. So AC square is 113. AC should be square root of 113. So what's the value of AC? AC value is square root of 113. Okay, let us find out what is sine theta and what is cos theta first. Sine theta is opposite side by hypotenuse. Adjacent side by hypotenuse is cos theta. Opposite side is given as 8. Hypotenuse is square root of 113. Adjacent side is given as 7. Hypotenuse is square root of 113. I'll substitute the value of sine theta and cos theta in this question here. Actually, to solve this question, we could have actually made use of something which is known as trigonometric identities, but I don't think in your reader it's not, trigonometric identities have not been mentioned so far. So I'm not going to make use of trigonometric identities here. I'll just quickly directly substitute the value of sine theta and cos theta in the question. 1 plus sine theta, the value of sine theta is given as 8 by root 13. 1 minus sine theta, by 1 plus cos theta. Value of cos theta is 1 by square root of 113. Okay, so I've substituted the value of sine theta and cos theta in this question. Now a plus, this is in the form of a plus b into a minus b, and we know that a plus b into a minus b is a square minus b square. Again, this is also in the form of a plus b into a minus b. A plus b into a minus b is a square minus b square. I know, you know, my handwriting on a graphics tablet is kind of messy, so what I'll do is I'll pretty much neatly write down the notes in a PDF format, and I'll include that as an attachment in this video, or else I'll you know, include a link to that PDF notes in the description of the video, so that it becomes so that the notes are readily available to you guys. Okay, so 1 square is 1, 8 square is 64, square and square root get cancelled, I get 113 here. 7 square is 49, square and square root gets cancelled here, I get 113 here. I'll just have to cross multiply. 113 ones are 113 minus 64 by 113. 113 ones are 113 minus 49 by 113. 113 and 113 gets cancelled. 113 minus 64. So what is 113 minus 64? It should be 49. (113 minus 49) should be 64, right? So cos theta is 49 by 64. I believe in the same way you can find out the value of second question, which is 1 plus sine theta by cos theta. You just need to substitute the value of sine theta and cos theta to find it out. I'll move on to question number 8. So question number 8 says, in a right angle triangle ABC, right angled is at B. If tan A is equal to root 3, then find the value of sine A cos A plus cos A sine A. So in this I'll just find out you know, the answer for the first bit. Second bit you can do it on your own. Let's do it. 8th one. It says tan A is root 3. Tan A is root 3. I'll have to find out the value of sine A cos C plus cos A sine C. Root 3 I can write it as root 3 by 1. Root 3 by 1 is nothing but root 3. Okay. I know that tan is opposite side by adjacent side. So I'll just quickly draw a right angle triangle here. A, B, C. With respect to angle A, BC is the opposite side. The slant line AC is always the hypotenuse. AB is the adjacent side. So BC is given as root 3. The adjacent side is given as 1. I'll again make use of Pythagoras theorem. AC square is equal to AB square plus BC square to find out the value of AC. AB, value of AB is given as 1. Value of BC is given as root 3. 1 square is 1. Square and square root gets cancelled here. So 1 plus 3 is 4. AC is equal to square root of 4, which is 2. So value of AC is 2. Now I'll just substitute the values of sine A, cos C, cos A and sine C to find out the answer to this question. Now With respect to A, this is the opposite side, this is the hypotenuse, and this is the adjacent side. Now we also have to find out cos C. So we'll draw one more triangle, a rough triangle. ABC. AB is 1, BC is √3, AC is 2. With respect to angle C, AB is the opposite side, AC is the hypotenuse, BC is the adjacent side. Okay, let's just find out. Sine A, everyone knows that sine is opposite by hypotenuse. So opposite side is √3 by hypotenuse is 2. Cos C, we know that cos is adjacent by hypotenuse. Adjacent side with respect to angle C is √3 by hypotenuse is 2. Cos A, with respect to angle A, adjacent is 1, hypotenuse is 2. Everybody knows that cos is adjacent by hypotenuse. Sin C, sine is opposite by hypotenuse. With respect to angle C, opposite is 1 and hypotenuse is 2. √3 into √3 is how much? √9. 3 3s are 9. 2 2s are 4. 1 1s are 1. 2 2s are 4. Square root of 9 is how much? 3. 3 by 4 plus 1 by 4. Take the LCM 4. 3 plus 1 is 4. 4 by 4 is how much? 1. So sin A cos C plus cos A sin C is 1. Okay, so we have completed exercise 11.1. There could be some people who must be thinking that an explanation in a local language like Hindi would be more helpful. For those guys, do not worry, I got you covered. I'll create a similar set of videos in Hindi too. That should be helpful. And as far as the notes are concerned, I believe my handwriting on a graphics tablet is a bit messy, as I told you earlier. I'll write neat notes on in PDF format, and I'll include that in the description. A link to that PDF notes in the description should help you. And there could be few people who must be thinking why this guy is rushing along during the explanation. I just do that so that the length of the video as such remains a bit shorter, because people when they look at the video, the duration of the video, they think that okay, this video is about 1 hour long. Oh my god, I'm not going to waste 1 hour on it. So you may have that kind of a perception. So I just rush along so that the length of the video remains small. And this is self-paced learning. If you feel that I'm going a little bit faster, you can always go back and replay the video. That way, that should help you. In case you have any questions or concerns, any queries, you can feel free to post them as comments on the video, and I'll certainly read those comments and I'll get back to you. So until next time, goodbye. In the next video, we'll be learning few basics which will help us in working on exercise 11.2, and hopefully we'll complete exercise 11.2 in the next video. Until then, goodbye.